Okay, the last topic in this lesson of division of polynomials is called synthetic division, and it's for special conditions. And if you go on in algebra or in calculus, you'll use synthetic division quite a bit. There is a section in your homework on synthetic division. You can use long division anytime, but when the divisor, which is the denominator of the polynomials, when the divisor has a certain format, you can use synthetic division. And when people learn this method, they sort of want to abandon long division as much as possible because it seems so much better, streamlined. And so you may have the inclination to do that, but synthetic division cannot be used every single time. Long division can. So you have to know both. You'll be asked to provide your work on both of those. So just keep that in mind. Okay, so first example here. First of all, the conditions are the same. You still need to have your polynomials set up in descending order. And if there's any term missing, you need to put in a 0 placeholder. So here's your first example. If I have x to the third plus 2x squared minus 3x plus 20 being divided by the binomial x plus 4. Okay, that one is in descending order. Everything's set up okay. Now, with this method, we're going to set up sort of an L-shaped boundary here, and I'm going to have 2 rows of numbers here, and over here I'm going to make a little shelf, so to speak. I'll explain that in a minute. And at the end, I'm going to have a little shelf made over here to indicate the remainder. So when we're setting up with synthetic division, we only use the coefficients, we don't use the variables. So the coefficients of this 4-term polynomial are 1, 2, -3, and 20. And they have to go in order, and I'm going to make that my top row here. Okay, so 1, 2, -3, 20. Okay, and this is going to create columns that I'm going to use as well in just a moment. Now, x plus 4 is my divisor, is going to produce a number, and the number is always the opposite of the second term here. So since this is positive 4, -4 goes here and becomes what I'm going to call the multiplier. Okay, so step 1 or part of the setup, sorry, is that the first coefficient always comes below the line. And then we're going to start with the sort of algorithm, I guess you can call it. Okay, so with this, instead of division, like we were doing with the long division, you're multiplying and adding. So instead of division included in subtraction, we're going to be multiplying and adding. So the one coefficient is here, is going to be multiplied by -4. Now, the result is going to go here. So -4 times 1, result goes here. I'm going to change to a different colored marker. This is all part of the setup. First step, -4 times 1, result goes here. And now it's time to combine or add, I guess you can call it. Okay, so 2 plus -4, and that results in -2. That goes here. Start again. -4 times -2, the result goes here. It's a +8 because a negative times a negative. -3 plus 8 gives us a +5. Start over. -4 times 5 gives us -20. Here's my little shelf for this part. Now, 20 and -20 cancel each other, and that leaves 0. That means our remainder is 0, so we don't have to worry about that fractional remainder. Now, these numbers become the coefficients of our answer. But here's where you have to consider the original degree of this polynomial. The degree of this polynomial is 3. When you divide by a polynomial with degree 1, your answer is going to be degree 2. So that's one way of looking at it. Or you can say, okay, here's my remainder, here's the constant, go up 1, here's my variable with degree 1, and here's going to be the coefficient of my variable that's degree 2. So it'll look something like this. 1 times x squared minus 2x plus the constant 5. Now, of course, when you type it in, you don't have to show the invisible 1. but I wanted to make sure that you understood that your coefficient here is clearly indicated here. Okay, we'll do another example next video.